Good morning. Assalamualaikum everyone. If your friend is not in here, please call them in. I see only 11 students. We should have 19 students. Okay, I have pasted the details in the CN as well. But if you realize your friend is not in, please call them in. Now we will proceed to our lecture on chapter numerical differentiation. This one, if you still remember in the earlier chapter that I skipped this part because I want to combine this with this chapter 5C topic. Okay, can you hear me clearly and can you see the slide? Can you hear me?
Miss, I can hear.
Can you see the slide now?
Yes, yes.
Okay, good. Thank you, Yongjin and Abdulghani for responding. Thank you, Ali. Okay, now we proceed to numerical differentiation. You might have came across this one in your, I think, in foundation, math 1 or calculus, if you take calculus. Okay. Now we call this as finite series. You will have a few types of finite series, which is forward finite. Yes, forward finite, backward finite, and centered finite difference. Now all of these should have the convergent trends. Okay, convergent. Okay, by now you should know already the terms of convergence and divergence. Now forward finite difference. It is differentiation. Okay, that's why you have F apostrophe over here. Differentiation, as we know, differentiation is dy dx. Okay, and then the terms that they use on dy dx, f prime x, f apostrophe x. So differentiation, in we know that dy dx. Let's say you have a curve. Okay, this is y-axis, x-axis. At x1 and x2, okay, the point. So dy dx usually it represents the gradient, the slope, where dy is the difference in y-axis. Okay, the difference in y-axis. X is dx is the difference in x-axis. Okay, so from this you get the slope, the gradient. Okay, so that's how this equation comes in. Fx plus h. H here is the step size. Okay, remember we have came across in previous topic, h is the step size. This is the h. Okay, x2 minus x1 is the h. Okay, forward means it moves forward. Okay, yeah, forward. Okay. Okay. Forward and you have x, x1. Okay, this is your fx. This is your fx1. Okay, which fx Okay, here fx plus h means that this is your h. Okay, so here from this equation, fx plus h here means your x1. So from here, fx1 minus fx, your dy, then over the dx, which is the h. Okay, forward, so it moves forward, a step forward, plus h. If backward, it moves backward, minus the h. Okay, let's say here you have your x is here. This is your h. Fx minus h here means this one. Yeah. Here let's say x negative 1, x naught. Okay, so this one is x negative 1 is x minus 1 is your x naught minus h. We move backward. Okay, so this is your fx negative 1. This is your fx naught. Okay, so that's why this equation comes in. The slope of that particular 2 points. Okay, fx minus fx x1 over the h. Okay, the h is the dx. So this is dy over dx. Now that one is backward, move backward, forward, move one step ahead. Now for centered, you see over here you have h, 2h, and the terms at fx plus h, fx minus h means you have this is x, x naught, x1, x backward, one step ahead, one step backward. Okay, so you have this point. Okay, imagine the correct line. Okay, so you'll have here if here okay, the correct line. And let's see the dy. Like that. Okay, so for centered, you have 2h over here. So this is your h, and another one is also the h. If centered is between the forward and backward point. Okay, so here fx is 1, fx1 over 2h. 2h, okay, this h plus this h. Means the distance from x1 to x negative 1. Okay, still it is dy over dx. Okay, it's just the slope. Okay, here I want you to understand the terms, how it comes out, this term with the h, and then what is forward, backward, and centered. So far clear? Okay, now we proceed. This is the visualization of the differentiation. Okay, here, this is centered. Figure C. Okay, centered. Now, centered, you see there's 2h over here. From x I plus 1, x I minus 1. Okay, so here is your x. Now, the true derivative from this curve is on top here, the true derivative. But we are using approximation. The approximation. So from backward, forward. So combine both, it is centered. Okay, here is your x. If forward just now, we only involve one step ahead. This one. So this is the approximation. True derivative here is the true value. Okay, true value. So true value you can calculate from the calculator on differentiation. Okay, so forward, always remember forward, you will see the equation plus h minus fx. Centered plus h minus h over 2h. Okay, centered between 2 points. Forward and backward. Okay, for each differentiation equation, you will have the truncation error. Okay, this one similar as in Romberg last time. Okay, truncation error. So forward, the truncation error is OH, order H for forward. Okay, centered, order H power 2, the truncation error. Okay, so the higher the order, it will be more accurate. Okay, first order approximation, second order approximation. Now just now from the figure, we can see that forward and backward is having the step size, will have the error. Okay, for centered, having the step size will quarter the error. Okay, so this is the definition. Now, we try this one. It asks you to use forward and centered difference approximation to estimate first derivative. Okay, first derivative. First derivative means f prime x. If it mentions second derivative, so f double prime. Okay, now the given equation is this. And at x 0.5 using step size of h 0.5. This is the given condition, x and h. And it asks you to repeat the computation using h 0.25. Now, first thing, find the true value first. True value here is the f prime x of this, the differentiation of this function. Okay, so try to find out what is the true value for this function. True value of differentiation.
minus 0.9125.
0.91.
Negative 0.91.
Okay. The rest get the same.
The same.
0.91. Okay, so that is your true value. Now, it asks you to use the x of 0.5 and h 0.5. Okay. Now, before we proceed, I just want to recall your understanding on differentiation. Now, this one, differentiation equation. What should it be? The differentiation equation of this. This one will be what? Come, let me know what is the differentiation equation.
4 times minus
Sorry?
0. 4
Minus
into 0.
over 3, then
3 into minus 0.15.
this one 0 point distance.
Minus 0.45 x square.
Then
Minus 1 x. X.
0.25. Okay, so this is the differentiation equation of the function. Okay, make sure you know. So in final exam, if we ask, write this so that at least you can get perhaps half marks. Okay. Okay, now we proceed with the differentiation x 0.5, h 0.5 thing. Forward and centered. So first thing, we need to know what is the equation involved. Forward equation, this equation. Okay, forward, I copy this. The centered first. Uncentered, this is the equation. The equation will be given. Just make sure you know how to use it and what are the infos that you require. Okay, so this is centered. Now, you need fx plus h, fx. Okay, how to get that? Fx plus h means one step ahead. Okay, find out what is your fx. X starting at 0.5. So 0.5. Now from there, sub 0.5 into the fx. Fx, not the f1x. Okay, so sub fx into this equation. And try to calculate what you get for your fx.
0.925.
fx 0.925. Yes. All get the same?
Same.
Okay, good. Then you need x plus h means x plus h. X is 0.5 plus the h means 1. Okay, this one x plus h. x1 lah. Okay. Now, what is the value when x equals to 1? Value of fx.
0.2.
0.2.
0.2. Yes. 0.2. Okay, then sub into the equation f prime x for the forward. So fx plus h is 0.2 minus fx over h which is 0.5. Okay, what is that?
Minus 1.45.
Correct. Okay, simple as that. Differentiation quite simple. This question, if we ask, we can score 1. Okay, so make sure you know how to do it. This is f prime x for forward. Forward. Okay, now we proceed to centered. Centered, it needs fx1, fx0. Okay, your x just now is 0.5. So plus h f1 here 0.5 minus h is 0. So add one more data over here. When x equals to 0, what is your x?
1.2.
1.2. Sub into the equation for centered. 0.2 minus 1.2. What is it?
It's fine.
Sorry?
-1.
Yes, negative 1. Correct. Okay, so this is for centered. Okay, as you see, centered is approaching the true value. Forward, the true error is quite high compared to centered. So that is why centered in the previous slide, it is second order. Okay, this one is second order approximation. Higher order. So you see true error is lesser compared to forward. Okay, try to repeat using step size of page 0.25. Okay, you try on your own for forward and centered. The h value, the x will be different, fx also will be different because h here is 0.25. Arrange your data first. Fx h 0.25. arrange your data based on your H. 0.25, so it will be 0.25 and 0.5. Then you have different FX. Okay, so you get for forward and centered for H0.25.
Negative 1.15.
1.15 for forward.
Yes.
Centered.
Negative 0.935.
The rest get the same.
The same.
Same, okay, good. Okay, so make sure you get the same value over here for forward and centered. Okay, actually the answer is already here. So this is how the same as what we did just now. Subs all the data f1 fx plus h fx. Okay, this one is the h. For forward with h 0.5 and 0.25. Okay, backward, if you do backward, make sure you use the correct equation, which is the fx minus h. Okay, this is, okay, this one, fx minus h. Okay, you get this. So take note on the true error. Lower h, then you will reduce the error. Okay, okay, so centered, lesser error. And you have smaller h. Okay. Any questions so far? Clear? Easy kan? Okay. Here it compares for the third forward, backward and centered for each H. Okay. So you can see how the trend of the true error. Now we try this one. Find the gradient of the graph y equals to e sine x, exponent sine x, plus 5x power x squared and x at x equals to 2. Step size of 0.5 using all differentiation forward, backward and centered. Okay, so this is your function. This is your starting point, your x. Okay, this is your h. Now you have forward, backward and centered. So forward will involve the x plus h, backward x minus h, centered will involve both of these. So you will need the data. Okay, generate the table. Your x is 0.5. So x minus x is 2. X is 2. X minus h is the point before the x. So here would be 1.5. And step ahead, one step to 2.5. Now find out your fx. Then you sort into the forward, backward and centered equation. Backward is fx minus centered. Exponent sine x, bukan sine x. So in your calculator, this one you should put the e sign and in bracket sine x. Remember the mode it involves sine cos, you use radian. Okay, what you get for forward?
$20.8102.
20 or 21?
20.8.
20.81.
Yeah.
The rest get the same?
21.163.
Yes, 21.17. 21.17. Okay, let's check. If you get different answer, let's check your fx. What is your fx for 1.5? 13.96, right? Two point four eight two six. Make sure your fx is correct. Forward, you should get this value, 21. Backward, what you get?
17.0.
Yes, 17.0422. Entered.
18.96.
Coming?
18.96.
18. I get 19. 0, 1079. Okay, how to know whether your answer is approaching the true value? Find out the true value from the equation. Okay, subs your equation, dbx, then submit into this equation. What you get for the true value?
18.890.
18.966. Okay, so from here you can see whether your answer is approaching the true value or not. Okay, from the answer that you get, it is in the range with the true value. If let's say true value you get 18.9, but your calculation you get something like 50, then something wrong with your values. Check back your values. Okay, can easy right? Any question before we proceed? Okay. Now this one, the earlier slide, I already explained earlier. Okay, similar. Okay, this is the equation that will be given to you during the final exam. First derivative, okay, make sure first derivative is this. This is for forward. Okay, forward. Forward. First derivative. Second derivative. So if the question asks you to do second derivative, subs the infos into this equation. Okay. Your level is not limited up to first derivative only. Question might ask up to second derivative. Okay, second derivative, then the question will mention the order, higher order or lower order. Okay, so this one is for forward, this one is for backward. Okay, backward, first derivative, second derivative. Now take note when you have second derivative, what are the infos that you require? Okay, x minus 1, x minus 2. If higher order for second derivative, you need up to x minus 3. Okay, for first derivative, higher order, you need this. Make sure you choose the correct equation. Okay. Now this is centered. Centered, it starts with first derivative and higher order. Straight away, h power 2. Okay, compared to backward and forward just now, it starts with h power 1. Lower order. Okay. First derivative and second derivative. Now, this one you can try later. This one example from the textbook. Okay, I want to proceed to final exam question. Where is it? Okay, this one test May 2019. Okay, this is test question. It asks you to find the derivative of given function by using forward and centered. So here it mentioned accuracy level of H2 for forward, so higher order. And third, H4, higher order. Okay, so now this is the equation that will be given in the final exam. You must make sure which equation refers to which. Okay, it won't be labeled, you must identify your own. Okay, this one, I want to give you the tips how to identify. Whenever you see x plus 1, this one is one step ahead, so this one is forward. Okay, forward, the lower order. Okay, here you see divide by h, so forward. Now this one, x I plus 2, I plus 1. Okay, so this one refers to this. Let's confirm on the forward. Yes. First derivative, forward, higher order. Okay. This one, second derivative. Second forward.
Miss, the formula will arrange like this.
Yes.
Okay.
So you identify first lah, which one equals to which method. Okay. I think I don't change the sequence. It will be like this. Okay, now back to here. Forward at level H2. So this is the equation that we require for A. Take note on what are the points, the data that you require. Fx I plus 2, I plus 1. It gives the h. Yeah, it doesn't give the h value. So let me check. What's the h? H 0.5, x equals to 3. H 0.5, x. Okay. If this info is not given, please ask. You need this. You need your x value, means your starting point, and you need the h value. Okay, the distance, the step size. So you need this is the equation involved for higher order. Okay, arrange the data that you require. Xi plus 2. And third, you need this one. Okay, we proceed with A first. Xi plus 1, xi plus 2. Okay, so your x is 3. X is 3. I plus 1 means x plus h. So H 0.5, 3.5, then 4. Then find out your fx for these values of x. Okay, try to find out what is your x, your fx. What do you get for A?
9.08.
Yes, similar to the answer given. Okay. Okay, before that, fx for the A, what is that? If x equals to 3, what is your fx?
It's 65.2.
64.
65.
Huh? 65.
65.2.
65.2. 3.5.
80.29.
Okay. 4.
96.34.
Okay. The rest get the same? They should get the same because both one's answer on the final answer is same as the answer given. Okay. Now for centered, for centered, this is the equation for centered. Level 4, h power 4. Okay, centered, from the equation we need this and this xi minus 1 and minus 2. So xi minus 1 and xi minus 2 means 3 minus the h, then minus, that is your data. Find out the fx, then sub in the equation. You should get similar to your A. Here you get for fx when x is equal to 2. Okay?
I think 38.17.
2.5.
51.21.
6.1 or 5.1?
5.1.
5.1 point
21.
2.1. Okay, 5.1. Okay, the rest please check. So your b first derivative for b, you get the same. And don't forget to find your true value so that you have a benchmark of the final value. Even though the question doesn't ask you to find the true error, actually the true value doesn't require for you to find. But I suggest you to find the true value so that you have one value to benchmark your answer. Okay, so you get the same for B, 29, or different,
29.008.
29.0.
Same, same.
Okay, so same. The higher the order, the closer the true value. This one, if you calculate the true error, 0 already. Okay. Any question? Is this one easy? No. Let's try this one test in year. Okay, now this one. May final exam, May 2021. It asks you to compute the gradient. So gradient here means the first derivative. Okay, make sure you know the terms. As I informed earlier, gradient is equals to dy dx, which means the first derivative. With the function of this, okay, this is the given function, at x equals to 0.55 with step size of n. N here is 0.03. Via numerical approach by using backward and centered. Okay, here it doesn't give you the order of the error. Since it doesn't mention, you can choose any order of the error. The easiest, choose the first, like centered, it starts with h power 2. Backward, h Okay, that one is the easiest one. It's up to you to choose since the question doesn't mention. So let's say we choose backward finite difference first derivative the first order O level H. Okay, backward. So here it will mean identify the equation. Okay, centered. So these are the data that you require. Okay, find out your data, find your fx and x. One step backward, one step forward. Okay, so your x minus h, x plus h. X is 0.55. Step size 0.03. Okay, find out the value of your x minus h and x plus h, or sometimes the term is x I minus 1, x I plus 1. Same. They all mean the same. Okay, so from there, find out what is your fx, then sub into the equation. Try whether you get the similar answer to the answer over there. Okay, do you get the same? What do you get for question number 1?
4.32.
4.32. The rest get the same?
Same.
Same. Okay. How about number 2, centered?
4.66.
4.66. Okay, so slightly different from the given answer, but it's still approaching the true value. Okay, so this answer is acceptable as long as it is approaching the true value. Okay, acceptable. Okay, I will advise you again to find the true value so that you know whether your answer is approaching the true value or not. Okay, so that's all for the differentiation. Any question? In CN, I have uploaded 4 sets of final exam questions, so I think it should be enough for you to practice. Try to do the differentiation question from those sets. Not that hard, this part. You can easily score. Okay, any question for this? No question, I will stop here. Next class, we will proceed the last topic, the Euler's enhanced method. I'll share with you the attendance for those who haven't scanned just now. Okay, can you see the attendance? It's shared, right? Okay, so that's all for today's class. Thursday will be our last class. After the lecture, I will recap all the topics and what the important parts of final exam. Okay, so if no question for today, you can leave the class. Thank you.
Thank you, Miss.
You're welcome. Bye-bye.
Thank you,
Bye-bye.
Miss.
Okay.
Miss, where can I get the midterm and test paper?
Thursday. I pass back everything on Thursday. I will announce NCN for collection.
Okay.
Okay. Okay, the rest have you scanned attendance? I will stop the class. I unshare. Please leave everyone. Bye bye, thank you.